This is part 6 of the linear regression series. In this video, we will look at the random sample consensus, RANSAC. This video was produced in Korean and translated into English. My voice was generated through AI, text-to-speech. Let's look at the outliers and RANSAC and the maximum number of attempts to find a consensus set. RANSAC is an algorithm proposed by Fischler and Bolles in 1981 to solve the location determination problem, LDP, in the field of computer vision. Given a photo depicting a set of landmarks with known locations, LDP determines that point in space from which the photo was taken. We will use this algorithm to perform the linear regression. Outliers in the data affect the estimation of the regression line. The estimated regression line may be biased toward the outliers. In the figure below, there are inliers, which are the normal data points, and outliers, which are abnormal data points. If you fit the regression line to the inliers, the regression line becomes the blue straight line. However, due to the influence of outliers, the actual regression line will be the red line. RANSAC is an algorithm that finds a regression line using only inliers, without being affected by outliers as much as possible. RANSAC iterates the process of fitting a regression line to a randomly sampled subset. This results in multiple regression lines, and the one with the most data points near the regression line is chosen as the final regression line. In the figure below, the red data points are sampled data. If you fit a regression line to sampled data points, it would probably look like this. And set the threshold range. There are 5 pieces of data within this range. In the next iteration, the sampled data points are all inliers like this. If you fit a regression line to this sampled data, it would probably look something like this. There are 9 pieces of data in this threshold range. Since there are more data points near the regression line B, we choose B between A and B. If all sampled data points were inliers by chance, most of them would be near the regression line. We need to determine the number of iterations so that only inliers can be selected at least once. This is the main topic of this video. The maximum number of attempts to find a consensus set. Presented in the section 2B of the paper. Now let's look at the problem of determining the maximum number of attempts to find a consensus set. First, let's find the expected value of the number of attempts, k. K is the number of trials or attempts, and N is the number of data points to sample. W is the probability that the selected data point is an inlier. Conversely, 1 minus W is the probability that the selected data point is an outlier. 2 to the power of N is the probability that all N selected data points are inliers. Conversely, 1 minus W to the power of N is the probability that N selected data points contain at least one outlier. Let's create the probability distribution table for the number of trials k. The random variable is the number of trials k, and the probability is the probability that all selected data points at the kth iteration are inliers. On the first attempt, this probability is W to the power of N. On the second attempt, this probability is like this. On the first attempt, there are outliers, and on the second attempt, they are all inliers. On the third attempt, this probability is like this. The first and second trials both contain outliers, and the third trial contains only inliers. Calculating the expected value of k in this probability distribution table is as follows. Let's w to the power of n be the b, and let 1 minus w to the power of n be the a. Then, the above equation can be written as follows. Here, if we take b out of the parentheses, it looks like this. And let's define s as the expression on the right-hand side. This results of this expression is like this. Differentiating the above equation with respect to a, we get the following equation. And the right-hand side becomes as follows. Then this part of the third equation becomes like this. Therefore, the expected value of k can be written as follows. Let me give you an example. If w is 0.5 and n is 4, the expected value of k is 16. The source of this content is the section 2.b of the paper. Next, let's find the standard deviation of the number of attempts k. The variance of the k can be written as follows. The expected value of k is this equation which we looked at on the previous page. And the expected value of k squared can be written as follows. This is the expected value of k squared from the probability distribution table. Here, we will separate 4a into two items like this, and 9a squared into two items like this. Then the above equation becomes the expected value of k. Now let's summarize the equation below. Let's define s as follows. If you multiply both sides by a, you get this. If you subtract the two equations, you get this. The results are as follows. Then s can be expressed as follows. Differentiating this equation with respect to a gives. The right-hand side becomes as follows. This is the result of summarizing this part. Then the expected value of k squared becomes as follows. Therefore, the variance of k can be written as follows. The standard deviation of k can finally be written as follows. The number of trials k follows a distribution with a mean of this value and a standard deviation of this value. Let me give you an example. If w is 0.5 and n is 4, the expected value of k is 16 and the standard deviation of k is 15.5. If we determine the appropriate number of iterations this way, k becomes 47. This is the maximum number of attempts. All selected data points are very likely to be inliers at least once during the 47 iterations. This time, let's find the maximum number of attempts from a slightly different point of view. This is the method using the probability z. Z is the probability that all n selected data points are inliers at least once in k iterations. Again, to the power of n is the probability that all n selected data points are inliers. And this is the probability that n selected data points contain at least one outlier. And this is the probability that given k iterations, every iteration will contain at least one outlier. And this is the probability that all n selected data points are inliers at least once in k iterations. This is the probability z. So z can be written as follows. If k is obtained from this equation, k can be expressed as follows. This is the maximum number of attempts we want to find. Let me give you an example. If w is 0.5, n is 4, and z is 95%, k becomes 47. This means that over 47 iterations, there is a 95% chance that any selected data will be inliers in at least one iteration. So this will be the maximum number of attempts. So far, we have looked at an overview of RANSAC and determined the maximum number of attempts to find a consensus set. In the next video, we will use this number of attempts to implement the RANSAC algorithm from scratch. Then let's use scikit-learn's RANSAC regressor and compare the two results. And let's use RANSAC to predict Boston house prices. Finally, we will compare the performance of Boston house prices predicted by OLS, TLS, LWR, and RANSAC.